Okay, today we start the operating system principle overview in the first part. Okay, in the beginning we will discuss what's the basic concept of operating system by going through some history of operating system and discuss the principle design of system by separating the mechanism and the policies. Okay. Some early operating system, they have these following terms. Batch systems, which means the operating system run a program to completion without other activities, and then go and run the next program. So programs are executed one at a time and completion after running the others. Okay, before running the others. And later because a program may not always use CPU, they need to use other I/O devices as well. So when a program is using I/O device, CPU become wasted, okay, because the system serve one program at a time, okay. So to increase the system throughput and utilization, multi-programming was proposed. So in 1960s, by this kind of operating system, they always maintain several programs in memory at a time. Okay, and then they switch the CPU to execute instructions of those programs. Okay, to achieve the high throughput and high resource utilization. Okay, so when the program is using I/O, the CPU will be released, and then operating system will select other process to run to use the CPU and so on. Okay, but in multi-programming, the release of the CPU and then switch to other program volunteer. So that means the operating system did not took off the privilege of a program using CPU and switch to and assign to other program. Okay, but later in time sharing systems, okay, that means the programming multi-program is preemption. That means in this time, the operating system have the privilege to took off the CPU usage from one process and then reassign to another program. Okay, the reason for that is that by this time, a computer may connect to several hundred terminals, and each user sitting in a terminal, and then they run its program. Every time they insert a input, it expect to get the response frequent, very quick. For example, within seconds or 10 seconds, okay, or within 10 seconds, and so on. Okay, so by multi-programming with preemption usually means every program only get a predefined time quantum of CPU time at a time. Okay, so whenever you get a privilege to use CPU, you only use a small fraction of time, and then the CPU will be released, take off by the operation and be assigned to other program. So every program will get a fair amount of CPU time. Okay, and to create an illusion that a physical CPU serve multiple programs simultaneously. Okay, and more or less fairly. Look like every program has or every user has a dedicated slower but dedicated CPU for each own program and so on. Okay, so we call it time sharing. That means the CPU time is shared by multiple programs. Okay, later, we have a portable operating system. Okay, the first portable operating system is Unix, which can be running on different hardware platforms. Before Unix, all the operating systems are associated or dedicated to a specific hardware platform. Because before that, every computer vendor, whenever they create a hardware, they also build its own operating systems. Okay. It started from 1970s. A lot of mini computer or workstation become popular, and not in that time to build up a hardware, it's become we cannot say easy, but become more reasonable task. So a lot of company they start to build physical computers. Okay, but to create or design an operating system usually require a lot of testing and whatever efforts. So because the design of Unix, they become easy to use an existing operating system which has source code and then port to different hardware platforms. So that's the philosophy behind this portable operating systems. And because the CPU usually contain two kinds of instructions. One is normal instruction, another privileged instructions. And the set of privileged instructions means this instruction can directly communicate or control the hardware resources. For example, CPU, memory, I/O port, and network, and so on. Okay. If a user program can directly use this hard privileged instruction to control hardware directly, then because the control hardware to make a specific hardware work properly, you need to carefully design this control sequence and so on. It is very highly skilled, so you need to an expert user to be able to do that. So, but normal application programmer, they don't have this knowledge needed to do that. So that's why an operating system to writing an operating system is very complex. Okay, some of the functionality require directly communicate with hardware. For those functionality, you need to be written by special skilled persons or programmers. Okay, and those do not need to use privileged instructions, those functionality which don't directly communicate with hardware, but they still are part of the operating system. Okay, they can be designed by normal programmer or whatever. Okay? So for many kind of reasons, so we try to separate these two functionalities or those two modules. Okay, which the modules which require directly use privileged instruction, and those modules they don't need to use privileged instructions. Okay, so for those modules or functionality, they need to use hardware privileged instructions. Those part of operating system we call kernel. So the microkernel operating system is this kind of operation. They separate the functionality operation based on they use privileged instruction or not. Okay, for those part they use privileged instruction. Though we kept in kernel mode, we call it a kernel. Okay, if your operation design they set based on they required the functionality required privileged instruction or not. Okay, so we call it microkernel operating systems. Okay, so the kernel, the operation, they have two parts. Okay, one microkernel, which those modules they all need to use privilege instruction, so they were kept together. And the other parts, for example, file system or whatever, they don't need to utilize privilege instruction directly. Then they can be running in normal mode, or sometimes we call it kernel user mode, and so on. Okay. And this kind of operating system are called microkernel operating system. Okay. The early example are Mark and Mimic. Later, we have personal computer become popular, and so the operation for personal computer has some its own history. Okay, the early stage, the popular dominant operation for personal computer is CPM. Okay, mainly used for Intel 8080 CPU machines. Okay, and later IBM PC and Microsoft, IBM and Microsoft team up. They create a personal computer center hardware architecture and DOS operating system. Okay, and then they become dominant hardware architecture and dominant operating system for personal computer for a long time. Okay, and later Microsoft they create Windows series. Okay. But starting from 1990s, there's operating systems which start from based on Unix, and they open source those OS codes. Okay, and so every programmer can download, can get this open source, the source codes and study and modify and create its own operating system for its own purpose. Okay. Then the example are Linux, FreeBSD, and NetBSD, OpenBSD, and so on. Okay. Starting from 2000, we have mobile computer. So their operating system will be Apple, iOS, Google's Android, and Microsoft's Windows Mobile, and so on. Okay. BlackBerry is early mobile computers. Okay, mobile phone. It has its own operating system also. Now we can start to say something about what is an operating system. In general, the first program running when the computer power on is the operating system. Okay. In general, that's true, but usually before operating system loaded and run, we have a bootloader which associated with the hardware. Okay. So a more correct way to say that is that first program loaded and running when the program start. After a computer start, will be the operating system. Okay. Because the bootloader usually you don't need to load because it already in memory. Okay, so maybe that's more correct way to say that. Okay, but anyway, in general, because the only purpose for bootloader is to load operating system. Okay, so usually we don't consider bootloader itself is a program. Okay. And also operating system is the program that they use to run other programs. Okay, because without the operating system, the user, if you own your computer without an operating system, you cannot run any user program. Yeah. You need to have an operating system to help user to run other application or programs. And also, operating system is the program that provide controlled access to resources. Here we emphasize controlled access. The reason we need to have an operator is that to access this resource, for example, CPU, memory, display, storage, network, and so on, it's difficult because without control and proper setup or access, the hardware may crash. Okay, improper access will make it crash. Okay? And so that's why usually we don't allow user program to direct access those resources. This access need to go through the help of operating system or the service provided by the operating systems. Okay, so those access are under control and the system will not crash. So that's the reason we need to have an operating system. Okay. So in summary, the hardware in here is Ethernet, Wi-Fi, disk storage, and so on. Cannot be accessed, can only be accessed by operating system. Application need to go through the middle layer of the operating system, the help of operating system. So operating is like a middleman sitting there. Okay, application and hardware need to use the functionality provided or service provided by operating system to access. The principle, the basic design principle for operating system is that usually we say we need to separate mechanism and policy. Okay, so first we will say what is the mechanism? A mechanism usually is a presentation of a software abstraction. Okay, it's an interface of a specific function. Okay, it defines how to do something. Okay? But policy defines how those mechanisms will behave. Okay. For example, when you drive a car, the mechanisms are the wheel. You can turn left, turn right, so the car will turn left, turn right, right? The gas, the gas pedal, when you hit, the car will run faster. When you release a little bit, the car will slow down. And there is a brake. Okay, when you hit, the car will immediately stop. And so those are mechanisms. Those are provided by the car itself. Okay, so it's a mechanism. But to drive a car bring a car from a place A to another place and go through another roads to avoid to collide to something. Those are policy defined by the driver. So driver driving a car means it defines a policy, make the car behave well, so the car can drive from place A to place B without collide to anything, and so on. So that's the definition of mechanism and policy. So a good operation should design in such a way that keep mechanism and policy separate. So those functionality we direct, communicate, or access resources are designed as a mechanisms. Okay, and how to interact with this mechanism or use this mechanism and become that the system behave some way, some specific purpose. to serve some specific purpose. Those are policies. Okay, if we can separate these two, then so the kernel, microkernel contain mechanisms, and the other operation functionality they define policies. So those are in user level and so on. And that's the way. So whenever you create an operation, you will try to pull an operation from a hardware to another platform. The only thing you need to do is you replace those mechanism part, because parts part may not need to be replaced. That means a good driver should be able to drive from by using car A one time from vendor A, or later you drive the car from vendor B. The mechanism may be different. As long as the interface provided by the mechanism are similar, for example, all cars have a wheel, have the brake, have the gas pedal, then the driver should be able to drive the different car by using similar policies. So you don't need to rewrite the code for those parts in the policy label, but you only redesign, rewrite those code to provide the same mechanism in the same interface, but maybe communicate in different hardware because the resource may be different. Although the car, the interface provided by different vendor of car, they are the same, but the underlying hardware may be different because it may be an EV car, maybe a hybrid, maybe a gas, and so on. So that's the way a good operation system should be designed. Okay, we will stop here.